So welcome to this next series of videos. For these ones, we're going to be looking at lots of different types of rings and all of the different versions of rings that Sonic Pi has. Well, when I say all, most of them. And then also how we might use them within our productions. I always think a really good place to start is the help library. You can see the icon just up here in the top right. Sonic Pi ships with a number of examples. And of course, you can use these to help you in terms of getting to know how to use the language, but also potentially use it for a basic production idea. The one that I want to draw your attention to is this one here, Reich phase. So it's based on Steve Reich's piano phase. The basic idea of piano phase was really two tape machines. And then just slowly both of them starting together, so they start in sync and then slowly sort of slipping out of phase. And then in the process of kind of this phasing then results in particularly interesting kind of transitions between stages, and then recognizably where they both sync up again. So his idea came from tape, which then he adapted over time into a number of instrumental pieces, of which piano phase is one version of his idea of implementing this kind of the phase-like properties of two or more tape machines running together, tape loops, and then transferring this into a kind of a musical setting. So the thing that I would draw your attention to is right up here, because the subject of this video and many others is basically the ring. So the ring that we have here is basically called notes, and then basically sequences of notes. Let's have a listen. So you can hear it sort of starting in sync, shifting, and then kind of coming back into sync, but revealing a new relationship, and then falling out again. So at the heart of this piece are basically two live loops, and really what you to achieve this kind of phasing effect is you've got one sleep that is 0.3, and this one is 0.295. So basically it's 0.005 less than this one. And so that's enough to create change over time. Both live loops address the same set of notes, which are in notes. And these notes are addressed as via the tick. So if you've seen some of the other videos when we've been looking at tick, each live loop has its tick. So with each iteration, the tick increases. What you would have seen from some of the other videos is that if we want to access the tick within that live loop for several items, then we use look. So we call tick once, and then for the remainder of the loop, if we need to access the same tick, the same number, let's say this one is going to play notes, instead of tick, it will say dot look. Right? Because the problem, which I will illustrate, let me just put the 0 and the point in front of that, shall I? 0.1. So the releases are 0.1. There we go. So you can hear that together. Let me pan 1 on the other side. Pan -1, and then, sorry, bad spelling. And then pan 1. Let me just code this bit out here. Now, we're not going to hear anything in terms of their various lefts and rights, because they are both essentially playing the same thing. So they will cancel each other out and just sound like they're coming through the center channel. There we have the look. But if we change that to tick, What tick does then is advance by one more. Every time you call tick, it adds 1 to whatever the number is. So even though they're both addressing the same notes set of values, rings here, they're actually addressing different parts. So if on the first iteration of tick, we're accessing this note here, E4, then when tick is called again, it goes to F#4. So when tick is called here, it goes to B4. So you can see that this then is a skip-based analogy. In other words, this one here is going to do anything that's 1, 3, 5, and this one is basically going to do the even numbers, 2, 4, 6, and so on. There are some advantages to using that. It's just not an advantage in using it in this particular setup, because it doesn't. It then, you know, let me just put that back in. If we play it against the phasing structure, the phasing live loop, which is this one, they're all addressing completely different things. This one here, the faster live loop, is addressing them one after the other, the values. Whereas here, we know that one tick is basically doing odd and the other tick is doing even. Okay, so that's the important stuff to do with tick. Let me take the pan off there. Rings here, I mean, basically we've got a set of notes, F#, E4 or E, D in terms of pitches, and then the register that they should be in. So E4 is the E above middle C. And if you've seen the MIDI notes, then MIDI note sort of middle C is MIDI note 60. So this is above 60, which is 64, because E is 4 semitones above. So this is what we're sort of engaging with here in terms of the ring. So the thing about rings is that they are safe. They're safe in that they operate like arrays, but they're immutable, which means that you can't change them in when they're running. You'll need to do something else to be able to change them in real time. But with the safety of being immutable, unchangeable, it means that these rings don't really crash unless we do something like misspelling or something like that. So a ring doesn't really need to access a particular index point. We can say access 0. The tick, it just basically manages walking through the ring. If we wanted to go the reverse, so rings also have a number of commands that go with them as well. So we'll be looking at those in some of the other videos, and those are called ring chain commands. Okay, until next time, bye for now.